In this question, we'll be designing a DFA to accept strings starting with A characters AA and ending with BA. So our first step is to obtain the regular expression and language set. So first, let's write sigma is equal to A and B. That is the characters which has to be used in the DFA. So we can write the language as it has to start with AA and end with BA. Or it could be AA, ABA, AABB, AABA, and so on. So here we need to remember that it is starting with AA and ending with BA in all these strings, possible strings. Followed by that, we have to write the regular expression, which can be written as it has to start with AA, fine. In the middle, there could be anything comprising of A and B followed by BA, which can be written as AA lambda BA. As lambda has no value, it is written as AA BA itself. So looking at the second step, we have to identify the wmin and design initial finite automata. So our step 2, that is wmin from L, can be written as AABA itself. As the length is 0, 1, 2, 3, 4, we can say that total number of states will be 4 plus 1, that is 5. So there will be total 5 states. Now let's design the initial FA, which will be Q0, Q1, Q2, Q3, and Q4 being the final state, and Q0 has to be the initial state. So here we have AABA, right? So let's write it here, AABA. Fine, we have designed the initial FA. Our step 3 is to define the transitions from each state on each sigma. So first, the transition of Q0 on A is defined, but transition of Q0 on B is unknown. Followed by that, transition of Q1 on B is unknown, Q2 on A is unknown, Q3 on B is unknown, Q4 on A is unknown, and Q4 on B is also unknown. So let's one by one solve this. So here we have Q0 on B is unknown, so let's write B, put it in a box, followed by AABA. Fine. See, in the language set, they have, in the question itself, they have specified that it has to start with AA and end with BA. So here, is it starting with AA? No, it is not starting with AA, but it is ending with BA. Thus, BA does not belong to the language set, so it will go under the trap state. Moving on to the next part, Q1 on B. So A is here, Q1 on B we need to know. Here we have A, B, A. So it has to start with A, but here it is starting with AB. So ABA does not belong to the language set. So it will go under the trap state. Fine. Moving on to this, Q2 on A. Fine. Before that we have AA. At Q2 we have to find A, and here we have BA. AABA, yes, it belongs to L. Let's solve it. Q0 on A gives Q1, Q1 on A gives Q2, and this side Q2 on B gives Q3, and Q3 on A gives Q4. So it is starting with Q0, ending with Q4, correct? So the only possible transition could be Q2 on A should give Q2 itself. So here we'll write it as Q2 on A should give Q2 itself. Going on to the next transition, Q3 on B. So before Q3 we have AAB, and here we have B. Q3 on B is unknown, right? So, and here A. So AABBA is a part of language. So let's start solving it. Q0 on A gives Q0 on A gives Q1, Q1 on A gives Q2, Q2 on B gives Q3. Here B and A is there, here A is there, right? So with A, it has to end with Q4 only, yes. And here it has to start with Q0 only. And here Q3 on B, the only possible way is Q3 on B should give Q2. So that's when Q0 and Q4, the sequence would be legal. So we can write as Q3 on B should give Q2. Next, let's move on to Q4 on A. So Q4 is here. Before that we have AAB, A, and here we have A. But is this a proper language? It is starting with A, but it is not ending with BA. So we can add BA here. So AA, BA, this A is what we have to find out, and B and A here. So if you solve this, AABA, it's from Q0 to Q4, and Q4 on A needs to be found out, and here BA is there, that is Q2 to Q4. So the only possible way could be Q4 on A should give Q2. So Q4 on A should give Q2. Followed by that we have Q4 on B. So let's write A, BA before that and B here. So is it ending with BA? No, we have to add A here. So Q0 to Q4 we have done. Q4 on BA is unknown, but BA starts from Q2. BA starts from Q2. So here B we have to find out. So here it will be Q3 and Q4. Thus the only possible way could be Q4 on B should give Q3. Q4 on B should give Q3. So now that we have obtained the transition states of all the possible strings, let's move on to step 4, that is to design the DFA and define MD value. So here I have designed the DFA from the existing initial finite automata, writing it as it is, and all the transition all the transition states which I've obtained in step 3 are being shown in the red colored pen. Moving on to defining MD value here. So Q value here comprises of Q0, Q1, Q2, Q3, Q4 and Q5 being the trap state. Then we have sigma, which comprises of A and B, and the transitions have been explained in the step 3, followed by Q0 being the initial state, and F, that is final or accepting state, being Q4. So moving on to the next step, that is drawing the transition table. Step 5, transition table, which is A, B on this side, and here we have Q0, Q1, Q2, Q3, Q4 and Q5. Q0 being the initial state, arrow, and Q4 being the final state, star. So Q5 self loop itself, and here let's start filling the values from the DFA designed above. So we have designed the transition table here. As you can see, our next step and final step is to take 2 strings to show sequence of moves made by the DFA design. One string would. So let's take step 6, W1, let's take it as AA and BA. So we have seen that AA, BA is legal. So if you even check from Q0, it will end up at Q4 only. Thus it is accepted. This belongs to Q0, and this also belongs to the final state. Let's take W2, that is AB, AB, AB. So let's take Q0 on A gives Q1, Q1 on B gives Q5, Q5 on A gives Q5, Q5, Q5 and Q5. Anything on a trap state would be the self loop here in this case. Thus, though Q0 belongs to Q0, that is initial state, but Q5 does not belong to the final state. Thus, this is rejected. So I hope you have understood how to solve this question. If you have any doubts, do let me know in the comments and subscribe to my channel. Thank you.